Hi guys, my name is Leif McGinnis. Welcome to my shop. In this shop I do machining, metalworking, woodworking, plastics, a little bit of welding, a little bit of everything. Most of the content that I create online is for Instagram, and I've done that for several years now. I make process videos where I kind of reveal, kind of how I make stuff as I make it in sped up videos. I don't make a lot of stuff for YouTube, but I thought I would try to kind of branch out a little bit. Over the years, people have kind of said, why don't you do YouTube videos? So just for fun, I want to make this first video on this sling. So I found this sling on a construction site in the garbage. And slings are designed for carrying really heavy things. And I've always kind of wondered, how do these things work? If you look here, they give you information about all the weight limits for the different scenarios, or depending on what you're carrying, how you're carrying it, they have that information. This is a Tufflex lift all. There's a serial number. This one's 12 feet long. They come in all different lengths, different sizes, some for carrying super heavy things, some for less critical applications. This one was damaged, as you can see, and it looks like someone tied a knot in here and tried to continue using it, and then at some point someone wisely threw it in the trash, which is where I found it. So I just kind of got curious how they're made. This is a continuous loop. It's just one big circle. So how does it terminate? A rope has two ends. So if this has all these it has a bundle of these fibers, is this a continuous circle? So what I found out is that it's actually all the same piece. These are all the same piece, just wrapped around. There's 34 of these little bundles in here, so it goes around 34 times. And then when it terminates, they actually just tie them in a knot. I watched a video on how they're made. It's actually pretty interesting how they do it. And it's just a normal knot. And part of taking this whole thing apart is these bundles. There's 34 of these bundles, and then each bundle is a whole bunch more fibers. I thought this was, a few hundred fibers. It's actually quite a bit more than that. And I kind of went down the rabbit hole studying this. I ended up putting these all inside of an aluminum tube, putting JB weld around it, cross-sectioning it, and I wanted to get a look at it. I wanted to count the fibers. So I ended up putting it on a microscope, illuminated it from below, and I was able to get a pretty good look at it. I cross-sectioned them and I glued them down to a little slide here. The idea was to be able to look at it on the microscope and just kind of have a manageable platform. I tried this a bunch of times. I'd like to say that it all worked the first time, but it didn't. I tried different colors. I tried clear, and there really wasn't enough contrast to really see what was going on. So I ended up using, the JB weld and the fibers. And this is actually quite thin. It's less than 10/1000ths of an inch thick, this little piece here. So this whole process, getting these little samples to work, this is probably maybe the 10th attempt. And I used the JB weld, which seemed to work the best. I'm using a fine-tooth Japanese saw to cut through it. The fibers are so fine that I found with the epoxy that it ripped the fibers out using a different saw. And after I cut through it, I pulled it off and I used silicon carbide sandpaper, and I'm wet sanding it. And I like wet sanding so I don't get dust all over the place. And that's Loctite 401 super glue. I'm gluing it down to a piece of acrylic. And after it was glued down, after it dried, then I would sand the entire thing on a nice flat surface. And I've got my microscope here, and it's lit from below with a Litra light. And here I am kind of tuning it in, getting it positioned properly and getting it focused. So this is my first attempt at a sample. So this is epoxy with carbon powder mixed in. I tried to create a contrast so you can see the fibers better. First time I did it, it was just clear epoxy. And I sanded it down, but as you can see, you can't really see the fibers, and yeah, it didn't really work that well. So this is the kind of image that I was really looking for, a really clean image where I could see all of the individual fibers,
all packed together. And so I sanded this thing up to 1000 grit using the silicon carbide sandpaper and wet sanding it. And the other problem I had was keeping it parallel, because if it's not parallel, then it's hard to keep every part of it in focus. So this is the best I could get, and then I'm pretty happy with it. So right now I'm just moving the slide around, and you can kind of see those red fibers in there. So those are just colored strands of the spectra fiber, and I think they're colored red to kind of help them see how the bundles are twisting. So the next thing is I thought, well, I've got this really clean image. I may as well try and count them. So I brought it into Photoshop and I counted them all. I zoomed in, counted them all one by one. And each color is a different zone. So each color is 1,000 fibers. So as you can see, there's way more than a couple hundred fibers in here. There ended up being 8,884 fibers per bundle. There's 34 bundles. That means there's slightly over 300,000 fibers in this sling. And if you think about it, in the vertical position, 8,400 pounds is the load limit. That means that 36 strands does the work to support 1 pound of weight. Kind of interesting to look at it that way.
All right, guys, if you guys found this interesting, please let me know in the comments. And if you guys have ideas for other videos to make, other things to explore, let me know in the comments, and like and subscribe. Thanks for watching.